All right. So it's a cryptocurrency exchange that exists as a protocol on the blockchain. So it's basically like a program software run on the blockchain. And so basically works like a normal exchange. You exchange one asset for another at a certain price. And then the main feature of it is that you're exchanging assets on chain. And so that comes with a number of like benefits. And so the trades are executed through transactions and smart contracts. Welcome. Just getting started, don't worry. And then so settlement is decentralized, thus trustless and permissionless. You guys probably heard trustless and permissionless before. Do you guys know what those mean? Anybody? All right, so trustless basically means that you don't have to trust any like third party to like deal with your like transactions or money, for example. It's all done transparently like on the blockchain. So you're really only trusting the code that is public. And permissionless means that anybody can use it. Like companies or services can like ban users or like have barriers for people, such as like certain requirements to be able to trade. There is not any of that on the blockchain. All right, so we're going to compare centralized exchanges to decentralized exchanges here. So a centralized exchange, aka CEX, it's often run by a company. The trades are executed through an order book, and we'll look at that in a bit. And you need to trust the exchange, like I was saying before with the trustless idea, and KYC requirements, which is know your customer requirements, required by law to combat like illegal activity and stuff like that. And that ties in with the permissionless idea that I was talking about. And then only the exchange earns from fees. And we'll see here that decentralized exchanges kind of democratize fees and the revenues generated by it. So a decentralized exchange, aka a DEX, it's run on the blockchain. Like I said, trades are executed through smart contracts, which are just basically like programs that live on the blockchain. We'll touch on that in a little bit. Like I said, trustless, and then no KYC requirements. You can be anybody. You don't need to give up your identity in order to trade. And then basically anyone can earn from fees as long as you're providing liquidity, which we'll also go over. So examples of popular centralized exchanges, we got Coinbase, FTX, Kraken, Gemini, Binance. You guys probably heard of those. All right, so how do centralized exchanges work? So basically, centralized exchanges, I don't know if you guys are very familiar with like financial markets in general and like how, like basically like the stock market, for example, how that's traded. Basically, there's an order book full of bids and asks. Bids and asks, first bids are someone saying, I want to buy at a certain price, and asks are, I want to sell at a certain price. And so those are orders that live on a book called the order book. And then people can take up an offer that's on the order book. And so that's how things are traded. And so the two types are market orders, where you buy the lowest ask, for example, and then, or you can sell to the highest bidder. And so basically when you trade on a exchange, you're normally doing a market order because that transaction has to be done quicker. Whereas if you're doing a limit order, you may have to wait for your order to be filled. And so price is basically determined by the last trade. In more efficient markets, the bid and ask, the distance between them, like the difference between them, it'll be lower, and so that's called the spread. And so the price trades pretty closely to either side of the bid-ask spread. And so price action happens when one side's orders are filled at a higher rate than the other side's orders. So if there's a lot of people buying one asset, for example, a lot of the ask orders are going to be filled. And so if you like kind of look at that image there, the red represents ask orders. So if there's not many ask orders, those are going to be taken out of the order book, and the price is going to go higher because the the asks that are lower are going to be taken out, and so the lowest ask will be higher. And so we can take a look at an example of an order book live on an exchange called Kraken. I can't really see it very well from my angle, but basically we've got the order book over here. So on top are the asks, because people want to sell at a higher price, right? You don't want to sell at a price that's lower than what's in between. And then below you have the bids. And then this over here, this represents the depth of the orders. So you can see a lot of people have bids set at low prices, because those are the dip buyers basically. When when Bitcoin, which is what we're looking at here, when that dips, these orders are going to be the ones that get filled. So a lot of people are kind of hoping that Bitcoin will dip and then their orders will be filled here. And then same is going on with the asks. If the price goes up, people want to sell at a higher price. And so the higher up you go, the more orders you get.
So do the limit orders become these?
The order book?
Yeah.
Yes, exactly. The order book is just a list of all the limit orders that are there. And so people that want to do like an instant trade, they just go to the order book and kind of do what's called taking the order. There's makers and takers. Makers are the ones that put orders on the order book, and then takers kind of are on the other side of that. Yeah, when you look at like fee schedules for different exchanges, there'll be like different rates for makers and takers, because they want people to have limit orders sitting on the order book. And so there'll be less fees for makers. All right, so now moving on to decentralized exchanges. Have you guys heard of any of these? Uniswap, the big one, Pancake Swap, Sushi Swap. Yeah, so how do decentralized exchanges work? Well, they run on smart contracts, which are basically programs that run on the blockchain. And they're basically just a series of steps, typically like transactions, different functions that most often transfer money. So a trade is basically just money being moved around in a certain way. And so they use what are called liquidity pools, which are a pool of both sides of a trading pair. So basically a basket of two different assets. And so in this basket of these two assets, the ratio of token or asset X to token Y is equal to the price. And trading token X for token Y will add your token X and take out the proportionate amount of token Y in terms of a set equation, which we'll look at in 1 second. And so the result of the smart contracts and the idea of liquidity pools is an automated market maker. And so there's no need for an order book, and it runs 24/7 automatically because the blockchain is always running. So in automated market making, users are the ones that provide liquidity to a pool to create a market. And liquidity providers earn fees from those trades. And the price of the tokens is determined by a formula. So the common formula is balance of token A times balance of token B is equal to a constant K. And so that's simplified as X times Y equals K. And K is a constant value that cannot be changed by a trade. And it only changes when there's a change made to liquidity depth. Like if someone adds liquidity or removes liquidity, K changes only then. And so this formula creates a price curve. If you kind of do the algebra, you get Y equals K over X, which creates that inverse function. I think that's what you call it. And so trades cause price movement along the curve according to the trading pair's liquidity. So that was a lot to take in, I bet. I didn't really get it at first, so I created this nice worked example. So let's say I want to make a market using this equation on Uniswap V2, for example. So I created a liquidity pool for our imaginary token UMN and USDC, which is a stable coin pegged to $1. And our, let's say UMN is already trading on like Coinbase, for example, and it's priced at $2. So there's people already trading this. The market, let's say, is efficient, and people decided, okay, UMN is $2, so that's what the fair market value is. So using that information, I add 500 UMN and $1,000 to the liquidity pool. So here's our liquidity pool. We have a balance, good ratio of 500 UMN and 1,000 USDC. And so my question is, why do I add 500 UMN and 1,000 USDC? Do you want to answer, Abdullah? Do you want to give someone else?
Is it because the price is $2?
Yes, that is exactly why. So why should I not add 1,000 UMN and 1,000 USD? What will happen then?
It will be $1.
Yeah, so basically, if I did that, you're right, the price would be $1 in our market. And so what would happen is that creates an opportunity for arbitrage. Arbitragers will see this opportunity, buy up our cheaper UMN and dump it on other markets, and they'll make a profit and will basically lose. And so our price curve equation is x times y equals k, as I said. So we multiply these two balances to get a constant of 500,000. And so the product of the quantity of UMN in the pool and the quantity of USDC in the pool should always equal that constant, assuming no one else is adding liquidity and assuming that I'm not removing any liquidity. So, so the more technical side, Quan, do you want to explain this part?
Sure, yeah.
So yeah, Quan will explain the transactions and stuff that go on behind this abstract overview.
Do you want me to like use Uniswap or like just explain on this?
Well, you could just explain the interface. I mean, if you want to go on the website, you can.
Okay, so this is something that you'll get to do later on. This is our sort of hands-on activity. But here what we're looking at is the Uniswap interface. So let's say you are, so yeah, let's start off at the top left corner. You see a pair between ETH and GC1. So this is a token that I created last night. Go for coin one, and you want to provide liquidity so that other people can spend ETH to purchase Gopher coin. So yeah, first you choose how much liquidity fees you want to charge. Here I set 1% because as a liquidity provider, I'm taking on risk. I'm not sure if the value of this token will go up or go down. So I need to make some profit from it. And then I also type in the starting price. So this is just a ratio between ETH and GC1. I put that as 1. And I can choose how much I want to deposit. And the unique thing about Uniswap is that it allows us to set sort of the bound, the interval between which I'm willing to provide liquidity. So what this means is, if let's say the price of GC1 falls below 0.5, and okay, so in what scenario would the price of GC1 go down? How would that happen? What needs to happen for the price of GC1 to go from 1 to 0.5? Yes, right?
A lot needs to be sold.
All right, so a lot of people would need to sell GC1. So trade GC1 in exchange for ETH, and that will bring the price down. So here I specify that if the ratio goes below 0.5, then I'll simply stop providing liquidity. So other traders cannot use my pool to exchange GC1 for ETH. I set the max price on the other side as well. And when after I specify all this, when I click on preview, this is what I see. So Uniswap creates a liquidity curve for me. And when other people start trading, I will start generating the 1% fee. And then maybe in a week or so, I can just come back to Uniswap and then claim the unclaimed fees. Any questions so far? Okay, cool. Yes.
Why would you just stop trading at the minimum price as opposed to just like offering it at that rate and then increasing your K? It sounds like you're just losing out on an opportunity to make more money.
Right. So what do you mean by with a higher K?
Right. So if like the real exchange rate is below like 0.49, right? So it's 0.45, but then you offer it at the 0.49 rate, then effectively what you're doing is with every trade, you increase your K because you're taking in more than you're putting out. So then isn't that just an opportunity for you to make more money?
Yeah. So you could think of this as like a limit order, but it's a stop loss order, where you say yes. If the current market price is 0.45, you can trade for 0.49 if you wish, but this will not go down below that amount, right?
Okay.
So that is to prevent, let's say, a very volatile market event happen and the price of GC1 just plummeted all the way down to 0.1. You don't want people to drain your pool. So that's why you said this.
Can you explain like the smart contracts that like get deployed and stuff like that, like the actual transactions on the blockchain when this happens?
Okay, well, to do that, we need a visual of the smart contract, I suppose.
I mean, just kind of like a broad like overview of what happens.
Yeah, on a high level, Uniswap has a smart contract deployed on the blockchain. And this is merely a front end that you can, click to trigger functions on the smart contract, but you don't need this front end. So if you just have a console and access to the internet, you could interact with the Uniswap front end without going through this website. And what happens when you click add liquidity is that it calls a function on the smart contract called add liquidity and specify the amount of ETH and Gopher Coin 1 that you are going to transfer over to the smart contract so that it can manage your money for you and handle transactions for you.
Yeah. All right, thank you, Kwan. And by the way, if you're confused about the price range stuff, don't worry about that. That's a feature in Uniswap v3, which I'll be touching on later. For now, just ignore that. Assume that the price range for liquidity is from 0 to infinity. All right, so now we're gonna look at what happens when we want to swap using this liquidity pool. So let's say you want to buy some UMN tokens and you go to this pool and you have $100 and you swap $100 worth for UMN. So your $100 US gets added to the pool. So new Y is equal to Y plus 100. So our new Y is equal to 1100 USDC. And so that's added to, that's our new balance in the pool. And so because the product of the token balances has to equal our constant, which is 500,000, new X has to be calculated. So new X times new Y equals K, do the algebra and you get new X is equal to 454.5 about. And so that gets changed. And now the difference between the old X and the new X is how many UMN tokens you receive. And so X minus new X is equal to 45.455 UMN. And so when you actually do this on Uniswap, for example, you type in how much you're offering basically, and then it'll output what you would get. So for example, if we were using our hypothetical liquidity pool, we would type in 100 USDC, and then out we would get what was it, like 45.455 UMN in the second box. And then you would just click swap and it would be done. But behind the scenes, what happens is you basically just send a transaction. And what that transaction does is add your 100 USDC to the pool. And then in that same transaction, you would also receive the UMN out of the pool. And so that is all done by interacting with a smart contract and calling different functions. And so we can visualize this price change on a graph. And so you can see that our price before was at the 0.500, 1,000. And because we bought it, and so the y-axis is in US dollars. And so you can see that in respect to US dollars, we push the price up because we bought UMN. And so that brings us to the next thing, price impact. So our purchase pushed the price up. Usually when you buy Bitcoin, you're not really moving markets. Your $100 worth doesn't do anything. But for us, we actually paid an average of $2.20 for each token. It's quite a bit more than $2. And so the reason for that is the price impact. So price impact is the difference between how much you actually pay and what the market price was. And so in this example, the price impact was 10%. And so now the new price of UMN in our liquidity pool is $2.42. So does anybody know why our trade impacted the price so much?
You're a market whale.
Yeah, pretty much. And yeah, in respect to this liquidity pool, there's not that much money in it. So our $100, it's a pretty big portion of it. And so there wasn't enough liquidity to kind of like support our purchase and not have so much impact on the market. And so in the real world, in decentralized finance, there are fees. Our example kind of disregarded fees for simplicity, but as we saw, Quan kind of showed that you can set a fee for your liquidity pool, and fees are typically a small percent of the trade. Yes, Wyatt?
I'm just curious why in the last example, the ending price was 242 and not 220.
That is a very good question. I was hoping someone would ask that. So basically, I noticed that I said you paid an average of $2.20. So as you so this is the result of $100 worth of the trade. Well, let's say you did like $2 increments, 50 times of $2 trades. That would cause the price to move up little by little. And so basically at each time you trade, you're trading at a higher price. But the average of every one of those little trades will be kind of like the midpoint, $2.20. Does that make sense? Cool. All right, so back to fees. Fees, when they're gathered, they are added to the liquidity pool, and it increases the value of K, so it causes the curve to shift to the right a bit. And when you provide liquidity to a pool, you get in return what are called LP tokens. And so the LP tokens are in proportion to your share of the liquidity pool. And so whenever you return your LP tokens, you get that share of K. So when K increases, your share, or not your share, but the value of your share of the liquidity pool also increases. And so another thing in markets is slippage. And as you may know, Ethereum blocks are not like instant. There's some time in between. It's like 15 seconds or so, I forgot. But so slippage is when the market price changes from the time that you place the order to the time that your order executed. And slippage can be good or bad. Like let's say you bought a token, and then like in between the time that you sent your transaction and it actually getting executed, maybe the price fell a lot, and then you were able to buy that dip. Like that could be a good thing. But usually it's kind of a bad thing because of like different front running attacks, which we'll get into later. And so slippage is an issue because, like I said, it takes longer for transactions to execute on blockchains. And so to combat this, decentralized exchanges like Uniswap often have protection built into the transaction to protect you from slippage. So like if the price changes by a certain percentage, the transaction will just fail and revert, and your transaction will not go through, and you'll be as if you never placed that order. And so the next topic here is called impermanent loss. Basically, this is a big topic when it comes to decentralized exchanges. This is like one of the it's like a critique of adding liquidity. And so detractors will say like don't add liquidity because you'll suffer impermanent loss, and they're not wrong. But what is impermanent loss? So simply put, impermanent loss is the difference between holding tokens in your liquidity pool and holding them in your wallet. And so this happens when you provide liquidity to a pool and the price of your deposited assets changes compared to when you deposited them. And so basically what this is saying is even if the value of your assets that you put in the liquidity pool, even if those increase, you're suffering a loss. And so this implies that liquidity providers are basically betting on the price remaining the same, but with high trading volume. And so because this is a really weird concept and I didn't get it at first, I created another worked example. So going back to our original market, we put in what we put in. And so in total, that's $2,000. And so UMN, let's say UMN trades upwards in other markets, and the new price is $10 because people really love UMN. So before our market reacts, before our liquidity pool, our traders react to that new price, our liquidity pool is still at $2. So this creates an arbitrage opportunity. So arbitragers buy up UMN in our market and bring the price up to $10. Now we have, after you do the math, you have 223 UMN and 2,236 USDC. In dollars, that's $4,000, $472. That's way more than our $2,000, right? Yeah, we profited. But if we simply held our UMN, we would have $6,000 worth of tokens. That's a $1,528 of impermanent loss. So basically we won, but really we kind of lost. But at a 0.3% fee, we would need about $500,000 in trading volume to make up for the loss. 500K is not that much when it comes to like big tokens, but since we're trading UMN here, like we don't have a lot of people trading, so that's a lot. And so on the flip side, we can see where impermanent loss isn't a problem, and that would be in markets where the pair are where the price is stable. So in a stable coin pair market, such as DAI to USDC, let's say we add $1,000 of DAI and $1,000 of USDC to liquidity pool, that's $2,000. And people swap their DAI for USDC and vice versa because they're the same price. So basically people are normally trading them back and forth depending on what they need. And so for every trade between DAI and USDC, we collect 0.3% per trade. After $1,000 in trading volume, we've earned $3,000, which is pretty good. And so because DAI and USDC are stable coins, each are $1, the ratio remains the same, and we just keep the fees. It's pretty good. And then also about that number 0.3%, actually, usually in stablecoin markets, the fee tends to be a bit lower. If we go back to this slide, you can see that the recommended amount of liquidity or fee for the stablecoin pairs is 0.05%. So that's just a side note. All right, so I mentioned before in the slippage slide that there are front running attacks. First, I'm going to talk about the sandwich price attack. So because the blockchain is very transparent, there's something called the mempool, which is kind of compared to a dark forest. So basically, when you make a transaction, your transaction has to be sent to all the miners in order for them to potentially include your transaction into the next block that they mine. And so what happens is that your transaction becomes visible before it can even be executed. And so this creates an opportunity for people to see what you're about to trade and kind of front run you and cause you to have a worse price. And if you have like a big transaction that has a bigger price impact, they can profit off of it. So I'll show you that here. So user A wishes to purchase 50 UMN tokens, which is priced at $2 on an automated market maker or a DEX. And so assume that this trade has a large price impact. So by the time that their transaction is executed, the price has moved up because of it. And so user B observes the mempool, which is where all the pending transactions are, and they see user A's big transaction. User B front runs user A by buying some UMN tokens with a higher gas fee. So gas fees are transaction fees. It's basically a way of bribing a miner to put your transaction in their block. There's basically a market where people want to have higher priority for their transactions, so they kind of bid up on the price, and that's kind of what creates a high transaction cost that we see today. And so because they have a higher gas fee than user A's transaction, this causes user B's transaction to execute before user A's. And so after user B's transaction executes, user A's transaction eventually executes and pushes the price of UMN up. And then after that, user B sells the UMN at a higher price than they bought, profiting from the price impact of user A's trade. So basically they knew that the price was about to go up and they bought some. And then once it went up, they dumped it. Like, it's a pretty good trade, you know, that's kind of like the perfect scenario, right? So yeah, that's one issue in DEXs basically. And then another issue are scams. So have you guys heard of a rug pull? If you're in the NFT space, you probably heard of that before. If you're in DeFi, definitely heard of that. And so basically how a rug pull works is basically, let's say I mint a new coin like UMN, but it's when we create it, it's worthless, right? Like, we got to give it value. And so we create a liquidity pool for the pair UMN and Ether, and we receive our LP tokens for providing that liquidity. And so let's say we run a marketing campaign, we want to attract people to buy it, give UMN some value. And so these traders that want to buy UMN because of our campaign, they buy the UMN with their ETH. And so they add more ETH to the pool and they take out UMN because that's how the pool works. And then after you get all these people to buy up your coin and then add their ETH to the pool, you withdraw your liquidity from the pool by returning your LP tokens. And now your liquidity is now composed of more ETH than you put in. So if you're still vibing with the UMN is worthless, then you kind of profited because now you have a lot more ETH. But there's a solution to this, and that would be locked LP tokens. So let's say you're an honest person, you wanna provide UMN to the market, you want to get your project started, you're an honest person. So what you do with your LP tokens after you deposit your liquidity is you put them in a smart contract that'll lock them for a certain amount of time. And then after that amount of time, then you can get them back. And hopefully by that time, other people have provided liquidity, so it doesn't hurt for you to get your money back. Any questions about anything that went over? Yeah.
Why doesn't everybody do this? This is literally zero risk because there's no UMN floating around. So in the worst case, you get your ETH back when your lockup period ends. And if anybody buys any UMN, then you are suddenly out ETH.
Wait, what?
This is
Are you,
like-
are you asking why people don't scam? I'm
Yeah,
confused.
no, people just make liquidity with a bunch of like new coins.
Yeah.
They do-
I mean, yeah, that's what people do. That's what rug pulls are. Any other questions? All right, so when Quan was talking about the Uniswap creating a new pool, there was a part where you specified a price range, and then there was another image where you could see like a little curve, and then there was like a little highlighted part that like kind of specified a range on the graph. And so these price ranges are a new feature in Uniswap and Uniswap v3. Everything that I went over is kind of based off of Uniswap v2, which just uses the x times y equals k, and that's it. But with v3, they introduced concentrated liquidity. And so in v2, with the x times y equals k purely, liquidity is uniformly distributed along that price curve that we saw from 0 to infinity. And so since liquidity is distributed along the entire curve, lots of liquidity may not ever be used, making the provided capital inefficient. And so, for example, stablecoin pairs only need liquidity in the 99 cent to $1 1 cent range. So all that liquidity that's sitting out like on other parts of the curve, they're not ever being used. So they're kind of just sitting there and just not generating any fees at all. So Uniswap v3 introduces concentrated liquidity to allow more efficient capital and deeper liquidity in important ranges. So the pros of this is that liquidity providers that provide liquidity in the proper range, such as a 99 cent range to $1, they can make a lot more in fees because a lot more of that capital is being used. And so deeper liquidity also means lower price impact for larger swaps. As we kind of like went over in the order book slide, when there's a lot of volume in one direction, when the liquidity depth is no longer there, then that causes the price to move. And then concentrated liquidity also acts as a more advanced instrument for betting on a pair. You can kind of bet that an asset will stay in between a certain range, and you're kind of just betting that it'll just kind of go up and down in between that range. And so all of that comes with the cons. Basically, it's just the opposite of the pros. So because you're not just throwing in money and just letting it sit there and being like, okay, whatever, like the liquidity is there, hands off now, I don't got to do anything. These ranges have to be more actively managed in order to provide liquidity at the right price. Because if you provide liquidity in one range, price goes somewhere else, none of that capital is being used. You're not making any fees because the price went like a different direction. And so unexpected price action can result in the opposite of the pros. Like if a lot of people provide liquidity in the wrong spots, then let's say like the price trades a different way that a lot of people provide liquidity, or so a lot of people expect it to go one way and they provide liquidity there. If it goes a different direction, then there's not going to be as much liquidity there, causing a lot of price impact when people try to trade in that range. So it's kind of an interesting debate, I guess. And so that is it. We'll have this, hold on, we'll have these slides linked in the Discord if you want to click on any of the references, and we'll also have some additional resources as well, I believe. So yeah, Wyatt.
I'm curious if you can charge like a higher rate for providing liquidity outside of the range. So like in case there's a massive swing, you would be able to capitalize on the sudden changes.
Quan, do you have an answer to that?
Yeah, I believe that's what Brand asked just now. So Uniswap doesn't have that feature. Like anyone can create something with that feature. I suppose like that's quite a bit of risk for the liquidity providers take on because yeah, it would be going outside the range. But that's not something that's currently in the market.
Okay. I also want to show you guys like kind of what we're talking about here. In the right place. I forgot where to find it. Remember where to see all the pools?
Yeah.
Was I on the right spot?
Yeah, you want to make
Oh, analytics, there we go. Okay, so let's take a look at some pools. So the first one I want to show is, I'll go with USDC and ETH pair. So if we look at the liquidity, we can see that the liquidity is pretty spread out. A lot of the liquidity is at the current trading price. And so if this was like Uniswap V2, I'm guessing liquidity would be more evenly distributed. But you can kind of see like where people are kind of like expecting the price to go, or kind of like or where they're prepared for the price to go. So like, let's say the price goes this way. I don't know if that's going up. Looks like the price is going down. So you can see people are more prepared for the price to go down this way than they are that way, which is kind of interesting. So yeah. And so now let's look at a stablecoin pair. Look at the liquidity here. Wow, look at that. People are smart. They're adding liquidity for the only range that matters. So yeah. Any questions, any thoughts on this? Yeah.
How does concentrated liquidity work when it comes to like, so you're not maintaining a constant K anymore. So then how does it work?
I don't know. That's a good question though. Anybody have any?
It's essentially shifting the curve so that the asymptote is your interval. So that it makes it, so normally the curve goes to a different value. But now if you specify the limit, let's say 10 on each side, then you basically push the curve upwards so that it reaches an asymptote quicker.
Oh, that's
Oh.
interesting.
Yeah, it's shifting the curve.
Didn't know that. Any other thoughts? All right. Well, cool. Thank you. Quan. Oh yeah.
I got a question. So, could you speak a little bit about like this in terms of regulation? Because I feel like there's gonna be some issues in regards to, like, I feel like it's a government official that they can, you know, people can rug pull. I feel like that's gonna be like an issue. Like how do we deal with that? Or what's the, like, or what do you think is the future of that?
Yeah, that's an interesting thing. So one thing I want to point out is that like regulation cannot like stop this, because it's all on the blockchain, you know, like it's permissionless, like anyone can access it kind of basically no matter what. And so there's an example of this where Uniswap Labs, the company behind Uniswap, they were I don't know if they were like forced to, or if they did this just out of like concern for themselves, but they delisted a lot of tokens that I forgot what the problem with them were. They're like synthetic assets or something like that. I don't know. But they delisted them from the interface that we were looking at. And so, but the thing is with that is that you can still trade those assets on Uniswap, because Uniswap is a protocol that you just some people just happen to use, or most people happen to use the website's interface for, but you can still trade it. You can make your own interface and send your own transactions. So like, there's no like stopping it, I guess you could say. But I guess it could be some like regulatory concern for, I guess, companies that are involved. Like, it's not so much concern for this slowing down. But yeah, some websites, like some projects in DeFi, you'll see that if you try to connect through a United States IP address, you just can't. So that's just out of concern, or that's just like the people that run it. They just don't want to have that problem on their hands. Does that answer your question?
Yeah, appreciate it.
No problem. All right, Quan. Yeah,
Do you have any rug pulls set up for yourself?
no. I'll actually never mind. No, I do not. I just had a good idea, but I don't think I should say it. All right, Quan. All right, what do we do now?
We can move into discussion. So like Brian brought up a lot of concepts. I'm just gonna list them down on the whiteboard and then we could like form groups and talk about more in depth.
You should use like I know, but like, we want,